Welcome to the deep dive. Today, we're tackling something that's really top of mind for many of you aiming for that senior software engineer role, mastering behavioral design patterns for technical interviews. It's not just about, reciting definitions. It's about showing you can actually architect robust and adaptable systems.
Exactly. Think of this as going beyond just knowing the what of these patterns to understanding the why and how they address real-world challenges in software design. We want to equip you with the insights to not just answer questions, but to lead the conversation and demonstrate genuine architectural thinking.
And that's precisely what senior roles demand, that ability to think holistically about system design. So we're going to deep dive into patterns that specifically manage how different parts of your system, the objects, interact and share responsibilities. We'll be covering the command, observer, mediator, and chain of responsibility patterns. These are really fundamental concepts that when you understand them deeply, they really shine through in an interview setting.
Okay, let's start with the command pattern. What fundamental problem does this pattern address in system design?
Well, the command pattern fundamentally addresses the tight coupling that can happen between objects that initiate an action and the objects that actually perform that action. So imagine an object, let's call it the invoker, that needs to trigger an operation on another object, the receiver.
Okay.
Without the command pattern, the invoker often needs to know a lot about the receiver and its specific methods. This creates a direct dependency, making the system less flexible and, well, harder to evolve.
So what's the command pattern's core strategy for breaking this connection? What are the essential components at play? Right, the command pattern introduces an abstraction layer, the command object. This object basically encapsulates a request as an object. Think of it as a self-contained unit of work. The key components, like you said, are the invoker, the object that triggers the action, the receiver, the object that ultimately performs the action, and crucially, the command object itself. This command object will typically have an execute method. The invoker then calls this execute method, and the command object, in turn, calls a specific action on the receiver.
Right, so the invoker just says, hey, command, execute yourself, without needing to know the nitty-gritty details of who will actually carry out the action. Now, for those preparing for senior-level interviews, what are the key architectural benefits that this decoupling brings?
Oh, the benefits are substantial when you're thinking about building resilient and scalable systems. Firstly, it offers significant flexibility in how senders and receivers are related. You can easily swap out different command implementations or target different receivers without the invoker even knowing. Secondly, because commands are now objects, you unlock powerful capabilities. Consider under redo, you can maintain a history of executed commands. For distributed systems, being able to reliably reverse operations becomes absolutely critical for data consistency after failures.
That's a great point.
You can also queue commands for deferred execution, which is invaluable for handling asynchronous tasks or, managing workload. And think about macro commands combining a sequence of operations into a single command becomes pretty straightforward.
That's a really insightful point about distributed systems. It's not just a UI convenience anymore, is it? So if I'm in an interview and they ask about designing a system that needs robust logging or the ability to roll back operations, discussing how the command pattern provides that structure through the command object itself would be a strong indicator of experience.
Precisely. Each command object can inherently carry the information needed for logging what operation on what data and when. For rollback, like you said, you can either store the previous state or implement an unexecute method within the command. Another key architectural advantage is the ability to parameterize objects with operations. You can pass different command objects around, essentially telling an object what to do without it needing to know how that action will be performed. It promotes a much more dynamic and configurable system.
It's like having a blueprint for an action that can be passed around and executed by different executors based on the context. Okay, let's pivot to the observer pattern. What problem in managing object relationships does this pattern aim to solve?
Right, the observer pattern tackles scenarios where you have a one-to-many dependency. Imagine one object, the subject, holding some important state, and multiple other objects, the observers, that need to be informed whenever that state changes. The core challenge is to make sure all these dependent objects are updated without creating tight, direct dependencies between the subject and each of its observers. You want the subject to be able to change without knowing the specific details of every object that's interested in its changes.
So instead of the subject having a hard-coded list of every object it needs to notify, there's a more decoupled mechanism. What are the key players in the observer pattern?
Absolutely. The Q components are the subject and the observers. The subject maintains a dynamic list of its observers and provides methods to attach or add and detach remove observers. When the subject state changes, it iterates through its list and calls an update method or some similar notification method on each registered observer.
Yeah.
The crucial thing here is that the subject doesn't know the concrete classes of the observers. It only interacts with them through a common observer interface.
And this notification typically happens sequentially, right? As we often see in diagrams of this pattern. For a senior engineer in an interview, what are the significant architectural benefits of employing the observer pattern?
Well, the primary benefit, and it's a big one for building loosely coupled systems, is that the subject and observers don't have direct dependencies on each other's concrete implementations. This means you can add new types of observers or remove existing ones without needing to modify the subject at all.
That sounds powerful.
It's incredibly powerful for implementing event-driven architectures where different parts of the system need to react to specific events.
Right.
Think about a user interface. Multiple views, which are observers, might need to update when the underlying data model, the subject, changes.
Right.
This leads directly to its importance in the Model View Controller MVC architecture, where the model acts as the subject, and the views are observers that update when the model's data changes.
That connection to MVC is a classic illustration, yeah. So if an interviewer poses a problem about building a system where various components need to react to a specific event, explaining how the observer pattern facilitates this with loose coupling and the ability to add or remove observers dynamically would demonstrate a strong understanding of architectural principles. Now let's dig into the mediator pattern. This pattern sounds like it's all about orchestrating interactions, correct?
Precisely. The mediator pattern addresses the complexity that arises from, well, numerous direct dependencies between multiple colleague objects. When these objects communicate directly, the relationships can become a tangled web, making the system difficult to understand, maintain, and evolve.
Like spaghetti kite for object interaction.
Exactly. The mediator pattern introduces a central mediator object that acts as an intermediary for all communication between these colleague objects. So instead of colleagues talking directly to each other, they communicate through the mediator.
So it's like a central control hub for communication. What are the key components involved in the mediator pattern?
You have the mediator interface, which defines the contract for how colleague objects interact with the mediator. Then you have one or more concrete mediator classes that implement this interface, containing the logic for how messages are routed and how colleagues interact. And finally, you have the colleague objects themselves, which hold a reference to the mediator and communicate with it rather than directly with other colleagues.
Okay, I can see how that centralized approach could simplify things in a complex system. What are the key architectural advantages that the mediator pattern brings to the table?
Well, the most significant advantage is the reduction of direct dependencies between the colleague objects. They only depend on the mediator interface. This centralizes the communication logic within the mediator, making the individual colleague classes much simpler and more focused on their core functionality.
Right.
This centralization also makes this system easier to modify and extend because changes in the communication flow or the addition of new colleagues primarily affect the mediator, rather than requiring changes across, multiple colleague objects.
That sounds particularly valuable when dealing with evolving requirements. Can you give us some concrete real-world examples where the mediator pattern proves particularly useful?
Certainly. Think about air traffic control. The control tower acts as the mediator, coordinating communication between numerous aircraft to ensure safety and prevent collisions.
Good one.
A chat room is another excellent example.
Yeah.
The chat server acts as the mediator, handling the distribution of messages between different users. In user interface development, a mediator can be used to coordinate the interactions between various UI components on a screen, making sure they work together harmoniously without having direct knowledge of each other.
Those are very clear and relatable examples. Now, how does the mediator pattern differ fundamentally from the observer pattern? Both seem to be about managing interactions between objects and reducing coupling in some way.
Yeah, that's a critical distinction to understand, especially for interviews. While both patterns aim to reduce coupling, they achieve it through very different mechanisms. The observer pattern essentially distributes communication. The subject broadcasts notifications to its observers, and the subject itself has no specific knowledge of who or how many observers are listening.
Okay, distributed.
The mediator pattern, conversely, centralizes communication.
Yeah.
All interactions between colleagues are channeled through the mediator. The trade-off here lies in reusability versus clarity of communication flow. Observer can lead to more reusable subjects and observers because they are less aware of each other. However, the flow of communication in a system using Observer can sometimes be implicit and, frankly, harder to trace.
Mhm.
With Mediator, the communication flow is much more explicit because it all goes through the central mediator, which can make it easier to understand and debug, but the mediator itself can become quite complex and might be less reusable as it's often tied to the specific interactions of its colleagues.
That's a really helpful way to articulate the core difference and the trade-offs involved. Okay, now let's move on to our final behavioral pattern for this deep dive. The chain of responsibility. What design challenge does this pattern address?
The chain of responsibility pattern is designed to decouple the sender of a request from the set of potential receivers that could handle that request. It achieves this by passing the request along a chain of handler objects until one of them is able to process it. The sender doesn't know which handler will ultimately handle the request. It just initiates the request and sends it into the chain.
So it's like a relay race for requests. What are the key components that make up this pattern?
Exactly. A relay race is a good analogy. The key components are the client, which originates the request, and a chain of handler objects. Each handler in the chain has an interface that allows it to receive the request and either handle it or pass it on to the next handler in the chain. Typically, there's an abstract handler class that defines this interface and the mechanism for forwarding the request. Concrete handler subclasses then implement the specific logic for handling the request if they can and deciding whether to pass it further.
And I understand that the composition of this chain can often be determined at runtime, offering significant flexibility. What other benefits does the chain of responsibility pattern bring to the table, especially when discussing it in a technical interview?
Yeah, beyond dynamic configuration, it offers the benefit of having multiple objects have a chance to handle a request. This is particularly useful in scenarios where the type of handler needed isn't known definitively beforehand, or where a request might need to go through several stages of processing by different handlers. It also strongly promotes loose coupling between the sender and the potential receivers, as the sender only needs to know the first handler in the chain, not the entire set of potential handlers. This simplifies the sender's logic quite a bit.
Can you provide some common real-world scenarios where the chain of responsibility pattern is frequently employed?
Certainly. Exception handling in many programming languages actually follows this pattern. When an exception occurs, it's passed up the call stack, which is the chain of responsibility, until a suitable exception handler is found that can deal with that specific type of exception.
Ah, interesting.
Event bubbling in web browsers, where an event on a specific HTML element propagates up the DOM tree until a handler for that event is encountered, is another prime example. Support ticket escalation systems also often utilize this pattern, where a ticket is initially handled by a first-line support agent, and if they can't resolve it, it's automatically passed on to a more specialized or senior agent in the chain.
Those are excellent practical examples that make the pattern much clearer. Now, looking across all four of these patterns, command, observer, mediator, and chain of responsibility, I can see a clear underlying theme. They all seem to be strategies for decoupling different parts of a system.
You've hit on a crucial insight there. That is indeed a central goal. These behavioral patterns are all about managing dependencies and interactions between objects in a way that promotes flexibility, maintainability, and resilience to change. However, as we've discussed, each pattern achieves this decoupling using a distinct approach and offers different trade-offs.
Right.
For instance, observer gives you very loose coupling, where the subject is completely unaware of its observers. Command uses an intermediary object to decouple the invoker from the receiver, providing flexibility in execution timing and history. Mediator centralizes communication logic to decouple colleagues, potentially simplifying individual objects, but at the cost of a more complex mediator.
And chain of responsibility.
And chain of responsibility decouples the sender from a specific handler by allowing a sequence of potential handlers to attempt to process the request.
It's fascinating to see how this core principle of decoupling manifests in such different ways depending on the specific interaction being managed. When preparing for technical interviews, it's probably not enough to just describe these patterns in isolation, right? It's also important to demonstrate understanding of how they might relate to and interact with other design principles and patterns.
Absolutely. You nailed it. In real-world systems, these behavioral patterns rarely stand alone. They often complement and reinforce each other, and they can be effectively combined with, say, creational patterns, which govern how objects are instantiated, and structural patterns, which deal with how objects are composed.
Okay.
For example, in a chain of responsibility, Each handler in the chain might utilize the template method pattern to define a consistent algorithm for handling requests, with subclasses providing the specific steps. Or a command object might be used to represent the request being passed along the chain of responsibility.
That makes perfect sense. It reinforces the idea of having a design toolkit where you choose the right tools for the specific challenges and understand how those tools can work together effectively.
Exactly. And that's what interviewers at the senior level are really evaluating: your ability to not just recall definitions, but to think about how these patterns can be applied strategically to build better software. It's about demonstrating an understanding of when and why to choose a particular pattern and the trade-offs involved.
So, to bring it all together, a solid understanding of these behavioral patterns, command, observer, mediator, and chain of responsibility is, well, essential preparation for anyone targeting senior software engineer technical interviews. It equips you to articulate your design choices, explain how your solutions promote flexibility and maintainability, and showcase your grasp of fundamental software architecture principles in the face of common design challenges.
Indeed. And as you prepare, think about projects you've worked on or maybe interview questions you've encountered. Where could you have applied these patterns? How might they have improved the design or addressed specific issues? Reflecting on past experiences through the lens of these patterns can be incredibly valuable.
That's excellent advice. And on that note, here's a final thought for you, our listener, who's preparing for that next big step. Considering the distinct approaches and trade-offs we've discussed for each of these decoupling patterns, the strength of binding, the flow of communication, the flexibility in handling requests, and what specific types of systems or scenarios might one of these patterns be a clearly superior choice over the others? What are the key factors that would drive that crucial decision? It's definitely a question worth pondering as you continue your preparation. Thanks for joining us for this deep dive.